1.3 States of matter. Observe different types of matter around you. What are its different states? We can see that matter around us exists in three different states: solid, liquid, and gas. These states of matter arise due to the variation in the characteristics of the particles of matter. Now, let us study about the properties of these three states of matter in details. The solid state activity. Do this. Collect the following articles: a pen, a book, a needle, and a piece of wooden stick. Sketch the shape of the above particles in your notebook by moving a pencil around them. Do all these have a definite shape, distinct boundaries, and a fixed volume? What happens if they are hammered, pulled, or dropped? Are these capable of diffusing into each other? Try compressing them by applying force. Are you able to compress them? Comment this. All the above are examples of solids. We can observe that all these have a definite shape, distinct boundaries, and fixed volumes. That is, have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside forces. Solids may break under force, but it is difficult to change their shape, so they are rigid. Consider the following. A. What about a rubber band? Can it change its shape on stretching? Is it a solid? B. What about sugar and salt? When kept in different jars, they take the shape of the jar. Are they solid? C. What about a sponge? It is a solid, yet we are able to compress it. Why? All the above are solids as a rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is applied, it breaks. The shape of each individual sugar or salt crystal remains fixed, whether we take it in our hand, put it in a plate, or in a jar. A sponge has minute holes in which air is trapped. When we press it, and the air is expelled out, and we are able to compress it. The liquid state activity. Do this. Collect the following: a water, cooking oil, milk, juice, a cold drink. B. Containers of different shapes. Put a 50 ml mark on these containers using a measuring cylinder from the laboratory. What will happen if these liquids are split on the floor? Measure 50 ml of any one liquid and transfer it into different containers one by one. Does the volume remain the same? Does the shape of the liquid remain the same? When you pour the liquid from one container into another, does it flow easily? Comment this. We observe that liquids have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be called fluid. Refer to activities 1.4 and 1.5 where we show that solids and liquids can diffuse into liquids. The gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. All living creatures need to breathe for survival. The aquatic animals can breathe under water due to the presence of dissolved oxygen in water. Thus we may conclude that solids, liquids, and gases can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids. This is due to the fact that in the liquid state, particles move freely and have greater space between each other as compared to particles in the solid state. The gaseous state. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? Inquire from him how many balloons is he able to fill from one cylinder. Activity. Do this. Take three 100 ml syringes and close their nozzles by rubber corks as shown in figure. Remove the piston from all the syringe. Leaving one syringe untouched, fill water in the second and piece of chalk in the third. Insert the pistons back into the syringe. You may apply some Vaseline on the piston before inserting them into the syringes. Leaving one syringe untouched, fill water in the second and pieces of chalk in the third. Insert the piston back into the syringes. You may apply some Vaseline on the piston before inserting them into the syringe for their smooth movement. Now try to compress the content by pushing the piston in each syringe. Piston, gas, rubber cork. What do you observe? In which case was the piston easily pushed in? What do you infer from your observation? We have observed that gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas (LPG) or the oxygen supplied to hospitals in cylinders in compressed gas. Compressed natural gas (CNG) is used as fuel these days in vehicles due to its high compressibility. Large volume of a gas can be compressed into a small cylinder and transported easily. We come to know of what is being cooked in the kitchen without even entering there by the smell that reaches our nostril. How does this smell reaches us? The particle of the aroma of food mix with the particles of air spread from the kitchen. Read us and even further away. The smell of hot cooked food reaches us in seconds. Compare this with the rate of diffusion of solids and liquids. Due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. The smell of hot cooked food reaches us in seconds. Compare this with the rate of diffusion of solid and liquids. Due to high speed of particles and large space between them. Gases shows the property of diffusing very fast into other gases. In the gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container. The pressure Due to this random movement, the particles hit each other and also the walls of the container. The pressure exerted by the gas is because of this force exerted by gas particle per unit area on the walls of the container. Solid, liquid, gas. A, B, and C show the magnified schematic picture of the three states of matter. The motion of the particle can be seen and compared in the three states of matter. Questions? Do this and comment this.